Welcome, Trig class. We are doing our lesson 47 online today. You should find this in packet J, lesson 47, vertical sinusoid translations, a second topic as well called arctan. If you would please, in your book, we are on page 330, 331. We're going to focus in on the sinusoidal graph to start with. We are learning sine and cosine graphing, started that last week. And you're going to see today that it's actually not a big change. We're just learning how to shift these graphs up or down a little bit. That's called a vertical shift. So you'll see on the image in your notes here, in the blue dashed lines, that's the original graph. And as a reminder, this is a sine graph when we start at the origin. It's going to go up and then to the middle again, down, middle, up. So this is a blue sine graph, and then there is a shift that you'll see, and it looks like it only shifted up about a half. So you're going to learn today how you can make those kind of shifts just up or down. The other topic we'll get to in a moment is on the right hand side, and that's arctan. So let's start off with our sine graph star 1. And the first thing I want you to focus in on that's new is here at the end. That is our shift. The vertical shift is going to sit either in front or outside the sine x at the end. And because it's a +1, we are going to be shifting up 1. So when I go into my graph, the first thing I'm going to do is I'm going to go and pick a different color that will just show what my new axis will look like. Since I'm shifting up 1, I'm going to go through and put a dashed line at where that 1 would be. And then that is now my center of my sine graph. Okay, and then the next thing I'm looking at is the fact that I have a 2 out front. And remember, that is called the altitude. So that means that the sine graph is going to fluctuate 2 above and 2 below, where that new axis is in dashed green. And because it is a sine graph, we are starting at the origin, only our origin shifted up 1. So we're going to start where I have that blue dot, and then sine naturally goes up first, then comes back to the middle, down, and back to the middle. And I'm going to carry that over to the left side of the y-axis as well. And you'll see when we have no transformation of the graph, stretching it or shrinking it, that it's basically every other hash mark that I'm putting a dot. Okay, so that's the hard part, getting those dots down. And then for some of us, maybe this is a little challenging too. We now have to go back and draw in with those dots, and we don't want to just make jagged straight lines. We're going to curve it like an actual sinusoidal graph. So I'm going to come back. And just hit each of those dots as we go. Okay, and that's what our graph looks like with a +1 shift up vertically. Okay, and then we're going to scoot over to question 2. And on this question, you'll see that we have a shift that is a -2. So that means we're going to be dropping down 2. So I'm going to start off finding where that would be on our graph. So I just drop down -2 and I put my dashed line. That's my new middle. Okay, and then I'm also taking a look at the 3 out front. That is my altitude. So from that dashed line, I'm going to go up 3 places. Oops. And then down 3 places. And that is the barrier for where I'm going to be drawing my cosine graph. Now, the cosine does not start in the origin. The cosine is smiling, so it's going to start up at the peak, and then it's going to come back every 2. We're now in the middle, and we're at the bottom, back to the middle, and back to the top. And I'm going to try to carry that over to the left side of the y-axis. Okay, so you have the outline of what that cosine graph is. And now we're going to go back and put in the drawing, curving it a bit as we go. Okay, so this is the cosine graph with a 2 shift down. All right, then the next thing we're going to do is go back up here to this part of our lesson. We're going to talk about the arctan specifically, so that is down here at the bottom. And we're going to be doing some range problems today. So what I need you to recognize is the blue shaded portion of our coordinate grid over here, which is showing us that the arctan is only going to be in these 2 quadrants. Okay, that's going to be important when we do a problem and we get a solution that's in a different quadrant. We know that we need to go back and change it. Okay, so the range tells us the output, and if our output is not in quadrant 1 or quadrant 4, then we have to go back and change it. All right, so we're going to try star 3. And the first thing I'm noticing is what's inside the parentheses is tan 45. Now, if you have your unit circle nearby, you may want to grab that. It makes it a little easier if you don't have it. I can just do a quick sketch off to the side to remind you where that is. That is in the first quadrant, smack in the middle. And we are looking for tan. So remember that that is our y value over our x value. Okay, so when it is a 45, 45, 90 degree, those 2 sides are going to be equal. So whether you use your unit circle or if you're using a calculator that does radicals, you can try that for these questions as well. But what I find out is the tangent of 45 degrees is equal to 1. Okay, then the part about arctan is now asking a different question. It's basically asking, when is tan of theta equal to 1? Is it only at 45 degrees? So if you look at your unit circle, can you find the y over x or the sine over cosine? When are they identical? Is it only at 45 degrees? And you'll find, nope, there is one other time that it is equal to 1. So I have 2 options. It's going to be at either 45 degrees or at 135 degrees. Those are the 2 times that I have tan equal to 1. Then I would think back to when my range is up at the top. It's available only in the first and fourth quadrant. So that allows me to basically get rid of this option. The 135 is not in quadrant 1 or quadrant 4. So my only solution to this problem is 45 degrees. Now you may look at that and say that was a waste of time because there it is at the beginning, arctan of tan 45, and the answer is 45. Yes, sometimes it comes out with the exact same answer, but sometimes it doesn't, so you do actually have to go through and check to make sure it's in the correct quadrant. Okay, so we'll have an example like that here on star 4. We have tangent of 120 degrees. Okay, so when I go to find 120, it is not in a good quadrant. It happens to be over here in the quadrant 2. And so when I find it on my unit circle, it's equivalent to negative square root 3. And so I'm asking, when is tangent of theta equal to negative square root 3? What other places? So we know it happens at 120 degrees, but we know that's not a good quadrant. So if you look on your unit circle, when else does that happen? That's going to also happen at 300 degrees. And that happens in the fourth quadrant. So that one is acceptable. And that will be our final answer. You'll notice in the Saxon book, a lot of times he shows the fourth quadrant as a negative. So this is also going to be an option to write it as negative 60 degrees. And that is something that Saxon has done quite a bit. So you just look for that, but 300 degrees is fine to write. Okay, and then we're going to go to the fifth question, finding the tangent of 210. So right away, when I think about where does that fall on my unit circle, 210 is going to be 180 plus another 30, so it's down here in quadrant 3. And then I check what is the value of 210, and it ends up the y value over the x value, they're both negative, so it ends up turning positive 1 over root 3. If it's rationalized, if you did it on a calculator that rationalizes, you might see root 3 over 3. But I know by looking at my graph that this quadrant is not acceptable for the range. So I need to find what is the other option. When do I also have tan giving me an answer of 1 over root 3? So I know it happens at 210 degrees, but I don't like that quadrant. And the other place that's going to happen is at the 30 degrees. Knowing that that falls in quadrant 1, that is my final answer. And then we're going to go to question 6. Find the arctan of tan 300. This one should be in quadrant 4. And it's going to fall down here somewhere at the 300 mark. What is the value of tan 300? You should find negative root 3 on your unit circle. And when that takes place, besides the 300, we also find it at the 120 degree mark. In fact, we did a problem up here just like it. And recall that 120 is not acceptable. That's in the second quadrant. So it's just 300 that we count as our answer. Okay, so that's it for the notes part. We're going to flip over into the homework section, and you'll see questions 7, 8, and 9 are highlighted. So let's go ahead and start with question 7. This is again in your book on page 331. You're going to have to look in your book to see the sinusoidal graph. The book is showing you a graph that has been shifted, and you have to look at the y-axis to see how much it's shifted. So what I noticed first of all is it does fall at the origin, so I know right away that I'm dealing with some kind of sine graph. So I'm going to go ahead and put sine x in here. Then I'm going to look for how much it was shifted. And the middle of it is falling in at a -5. Okay, so that means it was shifted down 5. So I put that in for my equation. And then the other part I have to look at is the altitude. That means how much did it shift up or down. So on the y-axis, you'll see that it is at the middle -5, and its highest point it is at 20. To find the difference of those, you would do 20 take away -5. So in other words, it has an altitude of 25. And then one more thing we have to look at, does it start at the middle and go up? If so, it's positive. Or does it start in the middle and go down? If so, this is a negative graph. And because it goes downhill first, we're going to put a minus out front. So this is my equation for the graph on number 7. Y equals -25 sine x minus 5. Then you're going to scoot on over to question 8. Same type of question. You have to look in your book, page 331. The graph presents as a cosine graph this time. So I'm going to go ahead and write out that much of it. And then I look to see how much the shift was. I can find the y-axis and see that it is shifting. The center point is now a -3 or a -3, so my shift is down 3. And then my altitude, because the highest point is at a 4 and the middle is a -3, that finds a difference of 7. So I'm going to have an altitude front of 7. And then for cosine, it's positive if it starts up top, negative if it starts down below. This one starts up top, so it is positive, and so this is my equation for number 8. Y equals 7 cosine x minus 3. All right, then we're going to scoot over to number 9. It's part A and B. These are the arctan questions. So for question A, we are finding the arctan of tangent 315. So if I have a visual of this over to the side, I have an idea of where it falls on the unit circle. It's going to be in the 4th quadrant. 360 would take us back up to the top again, or to the start again. So 315 is right smack in the middle over there. I can use my unit circle to find the value of tangent 315, and the value is -1. There are 2 places where tangent has a value of -1. And those are going to take place at 315 degrees or 135 degrees. Knowing that the tangent function has a range only in the 1st and 4th quadrant, that means the 135 is not a possibility, so our solution is the given 315. Part B, we're going to find the arctan of tangent 150. Okay, so tangent 150, I have a feeling is going to be in a quadrant we don't like. So 90 plus another 60 degrees, that puts us over here in quadrant 2. Okay, I check my unit circle and find what the value is. And it is at -1 over root 3. It's actually 1 over -root 3, but that's the same. There's one other place that takes place on the unit circle where the tangent is going to have a 1 over -root 3. So it happens at the 150 degrees, and it also happens at the 330 degrees. 150 is in that quadrant 2. It's not okay for the range. 330 is in the 4th quadrant, and that one is acceptable. So we're going to go ahead and mark 330 as our solution for that one. And then guys, we're going to try number 10 together. This was from the lesson last week, lesson 46, and I did have some absences, so I'm going to go through and do number 10 with you guys right now, just as a freebie. Question 10 asks for you to write a quadratic equation with a lead coefficient of 1, and it gives you your roots. So I'm going to write down what the roots are up here at the top. X equals 3 plus 2i, and then x equals 3 minus 2i. Those are the 2 roots that are given in the problem. We have to write the quadratic equation that uses those 2 roots. So the first thing I'm going to do is rewrite those as if they were set equal to 0. So that would subtract the 3 over and subtract the 2i over and set it equal to 0. And for this other one, I start out again by subtracting the 3 over, and this time I add 2i over in order to get it set equal to 0. Okay, so those 2 little pieces that I just discovered here are going to become the factors. Okay, so I'm going to combine them into one sentence now. I have x minus 3 minus 2i, and I have x minus 3 plus 2i set equal to 0. And then I need to FOIL that. Now, not only is it ugly because it has imaginary numbers, but foiling something when there are 3 by 3 parts, it can be very complicated. So fortunately, there is a shortcut I'm going to go through with you real fast. You'll notice that the beginning of each of these starts out with an x minus 3. And then the second part has the 2i. And in between, you have a minus and you have a plus. This is a special situation where we have a difference of squares. Okay, so there's a shortcut way to go back and FOIL these. The first thing we do is we take the x minus 3 and we square it. And we put a minus in between and we do the 2i and we square it and set that equal to 0. Okay, so x minus 3 squared, please, please, please remember that is FOILing. You must FOIL that whole thing. The second part, the minus 2i squared, that would become minus 4i squared equals 0. So I'm going to go back now and FOIL the x minus 3. So that would be x squared minus 6x plus 9. And then I have a minus 4i squared. Next, I'm going to simplify that minus 4i squared. I squared is equal to negative 1. Okay, so you need to think of that as really being a minus 4 times a negative 1. In other words, we're going to add 4. So I have x squared minus 6x plus 13 equals 0. And it did ask that our leading coefficient is a 1. We have that, so this is our final solution for number 10. Hope you guys have a great homeschool day.